So we're going to start out with the Bronsted-Lowry definition of an acid and a base. Bronsted was in Denmark. Lowry was in England. They formulated this idea in 1923. And what they said was, as you know from high school chemistry, that an acid was a proton donor. And they said that a base was a proton acceptor. And that's a reasonable definition for some of what we're going to talk about. But there was an alternative definition that was provided by Gilbert Lewis. Gilbert Lewis, who was an MIT professor, he was the founder of Lewis structures. You guys all know about Lewis structures, right, where you draw the electrons around. So Gilbert Lewis came up with an alternative definition at about the same time. Okay? And so Lewis's definition, which will be much more useful when we talk about catalysis, defined what we're going to call a Lewis acid as something which could act as an electron pair acceptor. And he defined what we're going to call a Lewis base as an electron pair donor. Interestingly, just out of curiosity, Lewis is probably one of the greatest chemists of all time, in my opinion. Not only did he come up with a Lewis dot structure and the Lewis concept of acids and bases, he also reformulated thermodynamics. He coined the term photon. He had a very long and distinguished professional career. He was nominated for the Nobel Prize 35 times. Okay? He never won it because he had an enemy on the committee who nixed his name 35 times. But brilliant, absolutely brilliant. One of the most brilliant chemists of all times. Okay. Now, let's review very quickly a little bit about acids and bases. Okay. So let me remind you that all acids have conjugate bases. So if I consider any old acid, HA, this dissociates into a proton plus A minus, and this is the conjugate base. This, of course, is the acid. Now, obviously, it's no surprise, then, that bases have conjugate acids. I could equally well write that some base plus a proton gives rise to BH. I'll make it plus in this case. Okay, and this, of course, is my base. And this is my conjugate acid. Okay, and you can see I can use either definition. Clearly, the base acted as a proton acceptor, right? So it meets the Bronsted-Lowry definition. But it also donated this electron pair. And so it met the criteria for a Lewis base. Okay. Now, we would all agree, right, that vinegar is probably an acid and bicarbonate is a base. But if every acid has a conjugate base and every base has a conjugate acid, how do we decide if something's an acid or a base? And really, of course, as you know, it's determined by the extent of dissociation of the proton, if we're talking in a Bronsted-Lowry way, right? So strong acids have weak conjugate bases. And by the same token, a weak acid has a strong conjugate base. Let me say it again so you can write it down. Strong acids have weak conjugate bases. And weak acids have strong conjugate bases. Now, strong acids you are familiar with, and those are things like mineral acids. So when we talk about a strong acid, a good example might be hydrochloric acid, for instance, or hydrobromic acid, or nitric acid, sulfuric acid, etc. And if we think about hydrochloric acid, the reason is because hydrochloric acid, as you know, dissociates almost completely into a proton and a chloride anion. Okay? Whereas weak acids only dissociate partially. I'm going to write one more thing up here. A weak acid, and a good example of a weak acid is acetic acid, okay? And that's CH3COOH. And for this only dissociates a little bit into the acetate anion plus a proton. Acetate, acetic acid. And you can see I'm intentionally drawing the arrows to indicate which direction the equilibrium for this lies in. Okay? Now I'd like you to notice that there's nothing here. There's nothing here necessarily about charge. Okay? In acetic acid, the acid is neutral, right? And the base is negatively charged, right? But I could just as easily consider, for example, I could consider ammonium, NH4 plus, right, which dissociates into ammonia plus a proton. And in this case, the acid is positively charged and the base is neutral. So don't confuse charge with something being an acid or a base.